Okay, so graph this function on your calculator, draw a sketch. It looks like this. Hey, where's an x-intercept? You can tell by the denominator. An x-intercept at -1. If we plug in 0 for x, where's the y-intercept? 1. And then, is there a vertical asymptote? Oh. Hold it, I did that wrong. Where's the vertical asymptote? The vertical asymptote comes from the denominator. Yeah. Okay. There's the vertical asymptote. The x-intercept comes from the numerator. How do you get the root for the numerator? What did we always do when you find the root? Set it equal to 0 and solve. So 3x plus 1 equals 0. Then it's going to be 3x equals -1 and x equals -1/3. So it's very small here. So it's going to cross the x-axis at -1/3. It's going to come up and do something like that. It looks kind of like that. Do you agree? Yes, I know you do. Okay. So go to your table, and here's how you get it. Do you see the graph button on your calculator? Right above it, it says table. So do second graph, and now we have a table of values. It should look like mine. It doesn't? It should only say error in one spot.
Oh yeah, -1.
At -1. And what's happening at -1? The vertical asymptote. Yep. Okay. It says examine the y values as the x values tend towards positive infinity. So I'm going to press and hold the down arrow. And what do you notice about the y values? Are they getting bigger?
Yeah.
Do they keep getting bigger by littler and littler amounts?
Yeah.
What number does it appear that they are getting close to but never reaching? 3. Yes. That's exactly right. No. As x approaches infinity, the limit of y equals 3. This is what we say. Because the farther out you go along x, the closer you get to 3, but you never reach it. We have, in this direction, a horizontal asymptote at 3. So, as the further out you go on x, the closer you get to this horizontal line at y equals 3, but you never get there. Well, we haven't explored that yet. Okay. So this is what we say. We say as x approaches infinity, so the farther out that you go, the limit of y equals 3. It means that the y value gets close to 3 but never reaches there. We could also say this. We could also say as x goes towards infinity, y goes towards 3. Now I'm curious, is it approaching 3 from below or from above? It's coming up from below. It's like it's underwater and it's trying to come up to the surface. Okay? And so, do you see how it's coming up from the negative side? So we put a post superscript negative. Or we say the following: the limit as x goes to infinity. That's cursive writing for those of you that didn't learn cursive. LIM, the limit as x goes to infinity of the function y equals 3. Those are 3 different ways to say that as x gets really big in the positive direction, y gets really close to the number 3. Okay? Let's do the same thing. Let's go back to our calculator, and let's go in the negative direction. Oh, mine doesn't want to go up. What's up with that? Oh, you got to be on the x's. Yeah. So I'm going to scroll up the other direction and see what happens. Hey, I'm going to show you a trick. You know what's taking so long to scroll? Watch this. Do you see the button that says window?
Yeah.
What does it say right above it?
Table set.
Table set. This doesn't mean forks and plates, knives and spoons and napkins. Okay, do second window. Do you see the button where it says TBL start? Put a 0 there. Table start, press enter. Then go second graph to go back into your table, and where are you starting? At 0. So now scroll up, and what do you notice the y value doing? No, it only does the error at the vertical asymptote. Keep going up. What do you notice? It's getting smaller and smaller. What number is it approaching? Look at, the farther I go out in the x direction, the closer I get to 3, but am I ever getting there? No. So what's going on is that there is this horizontal asymptote goes in both directions, yes. Because there's rounding error.
Oh, yeah.
Because your calculator only has 3 decimals, yes? 4 decimals, yeah, it's rounding error. Okay. As x approaches negative infinity, the limit of the function y equals 3. So that's the first thing that we could say. Or we could say as x goes towards negative infinity, the y value approaches 3. As you go bigger negative, is the function coming down from the top or up from the bottom? It's coming down from the top. So we would put a post superscript plus to show that it's coming from the top. Here's how you know that. Do you see how this direction over here is negative infinity? Is the function on the positive or the negative side of the asymptote? It's on the positive side. Hence the positive. At positive infinity in the x, is the function on the positive side or the negative side of the asymptote? On the negative. And that's why we wrote negative. Okay? Or we can write the limit as x goes towards negative infinity of the function y equals 3. Those are all different ways to say that when x gets really big or really small, the y value gets really close to 3. Okay? Now, with your calculator, press the graph button so you have the picture on your screen. Now press the trace key and press 0, enter. Now use your sideways arrow and scroll to the right and watch the y value at the bottom of the screen. Do you see it getting bigger and approaching 3? Do you see that? Okay. Now you can do the same thing in the other direction. Go to negative infinity. And do you see how the y value approaches 3 from above? Do you see that? Yeah. Yeah. So, what is happening to the y values as you trace along the graph? Y goes towards 3. Is this matching what we found above in the table? Yes. The y values are going towards 3. The trace function matches the graph function. So what I'm trying to help you with is when you're looking at these horizontal asymptotes, you can trace the function using the trace on the graph or using the table. Either way. Okay? Let's finish. Oh, we still have 10 minutes. Well, let's do a little more. Let's see if we can finish this page, and I think we'll call it good. Okay. Looking at this equation, y equals 3. Oh, there's an error on here. This is supposed to be, what is it supposed to be? 3x plus 1. Shame, shame, shame on Dave. Okay, typo. Okay, as you look at this equation, y equals 3x plus 1 over x plus 1, can you explain why the function's values get closer and closer to the value found above, which is y equals 3, as the x values tend towards positive and negative infinity? Okay. Well, this is what I have to say. As x goes towards infinity, or negative infinity, the plus 1 terms become insignificant. Okay, here's how I'm going to try and explain it. If you have 3x plus 1, if you plug in a number 1, 3 times 1 is 3 plus 1 is 4. All those numbers are about the same size, right? But what if we plug in 100 million billion, like a really big number, and then you add 1? Are you really even going to be able to tell the difference? No. The 1 is insignificant. It's like if I win the lottery, $125 million, you know, if they tell me that, well, you know what, we're short $1, you only get, you know, 125 million less $1, you know what, I don't care, because really it's all the same. Okay? And so what happens we have this y equals 3x plus 1 over x plus 1. As x goes towards infinity, or negative infinity, y becomes approximately equal to 3x over x, because the plus 1 terms are insignificant. And can you simplify 3x over x? The x's cancel, and it's equal to 3, which is your horizontal asymptote. Isn't that awesome? So, what is the equation for the horizontal asymptote of the equation? Y equals 3 is the horizontal asymptote. Indeed, all that work for y equals 3. Shall we call it quits?
Yeah.
All right.